Hello good day viewers, let us find a solution to this inequality. This inequality is very simple yet very interesting. 1 divided by x is greater than 1. So we want to find those set values of x that can satisfy the inequality. Before we start, you should know that x cannot be 0 because if x is 0, the whole system is undefined. First of all, let me show you the wrong way to solve this problem. We can simply multiply both sides by x. So to the left hand side, if multiplied by x, you have x divided by x, which is 1 greater than 1 times x is x. This implies that what? X is less than 1. So if x is less than 1, we mean all those values that are less than 1 can satisfy this inequality, though we have seen that 0 cannot satisfy it. So let's check other values of x that are less than 1. I know we can have negative 1. And 1 divided by negative 1 will give us negative 1. And negative 1 is not greater than 1. So this is not true. What about if we have negative 2? We have 1 divided by negative 2, which is negative 0.5. And negative 0.5 is not greater than 1, rather less than 1. So in fact, any value that is less than 0 will be negative, and 1 divided by a negative value will give us a negative value, and all negative values are less than 1. So what is the right answer? We can find the real set of values on the number line, because we can see that if we have 1 here, we shall have 0 here. So we have seen that x is less than 1. So we are talking about values from 1 down to the left hand side. But we have seen, according to our test, the moment we test a value here which is less than 0, it will not satisfy. So does it mean that the solution is within 0 to 1? Well, but there are a lot of infinitely many values between 0 to 1, decimal numbers. 0.1, 0.01, 0.001. All these values are between 0 to 1. So there are infinitely many. So are we just to assume? I don't think this is a right approach. If this is the case, let us try another approach. I know we can take 1 to the left hand side. So we have 1 divided by x minus 1 greater than 0, because we have nothing to the right hand side. And if you subtract 1 from 1 divided by x, you are going to obtain 1 minus x divided by x greater than 0. What does this imply? It means that this is a positive number, right? Because it is greater than 0. So on what condition would this fraction be positive? If the top is positive and the bottom is positive, the output will be positive. And if the top is negative and the bottom is also negative, negative divided by negative will still be positive. So these are the two conditions. So if the top, which is 1 minus x, is positive and the bottom is also positive, it will hold. We'll get a positive result. At the same time, if the top, which is 1 minus x, is negative and the bottom is also negative, if you divide negative by negative, you get positive. So now let us solve this one. By taking this one to the other side, we have 1 greater than x, or simply x less than 1, all the same. And from this other one, if you take this one to the other side, it becomes positive. So we have 1 less than x, or x greater than 1. So these are the two conditions. We are going to test them. On the number line, already we have seen that we cannot go to the left side of 0. So suppose I have something like this. I have 1 here and I have 0 here. This is what? X less than 1. So from 1, you move here. This is less than 1. And x greater than 0, it means from 0 you move to the right hand side. So you see there's a solution here, which we have already confirmed. So if we are to take this solution, it will be 0 less than x less than 1. Or in an interval notation, you can say x belongs to the set of values from 0 to 1. So what about the other one? If we should consider this inequality, x is greater than 1. This is x greater than 1, moving to the right. Or x less than 0, moving to the left from 0. And we have seen that all negative values cannot satisfy that inequality. And what about if we take numbers like 2, 3, 4, 5, which are greater than 1. Let me see. If we take, for example, 2, we plug it here. 1 divided by 2 is 0.5, and 0.5 is not greater than 1. And hence, we are going to discard this solution and consider this one. So x is less than 1 or x is greater than 0, which is either this or this. And let me show you another approach, which I think is the most simplest one. Since we have a closed interval, we can multiply both sides by x squared. So 1 divided by x greater than 1. 1 divided by x greater than 1. Let's multiply both sides by x squared. So this is x squared. This is also x squared. 1x will cancel 1x here. So we have x greater than x squared. Take this one to the left. We have x minus x squared greater than 0. Factor out x. We have x 1 minus x greater than 0. So it's either x greater than 0 or 1 minus x greater than 0. And from here, you can take this one to the other side. You have 1 greater than x, which implies x is less than 1. So we have either x greater than 0 or x less than 1. If you combine the inequality, you have 0 less than x less than 1. Or in an interval notation, x belongs to the set of values from 0 down to 1. And this is just the solution to this inequality. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.